Well, hey there, folks. Welcome back to the Speaker Builder channel. And today we're going to be talking all about amplifiers. Amplifiers matter a great deal because they drive the speakers that we're listening to. And amplifiers include a number of components internally that the signal path has to travel through, and each one of those is going to have a characteristic to it. Amplifier designers talk about, when they're designing an amplifier, they talk about voicing the amp, getting it to have a certain character to it that they're after. And every amplifier is going to have a little bit different a character to it. Now, if you have a passive speaker system, as I do for this amp, I drive a passive 8-inch two-way system. It's a little tougher to hear a difference. I can hear a small difference between these two and between these two with that system. But in an active speaker, especially with hard dome tweeters as I have here, the difference starts to be more significant. Now, in my case, the reason why I'm chasing this whole project is because I'm driving these very bright hard dome tweeters. The equivalent today you can get, these are focals that you can't get anymore, but the equivalent today are the Etons. They're $140 or $200 depending on which one you get. Very expensive, ceramic coated. They sound very much like these, so they're wonderful. I have a pair of them in my 8-inch two-way system, but because they're so bright and because there's no passive crossover parts here, it's an active system, these can be a bit much. And so it depends on a lot of other components in your system. And we're really in uncharted territory. When you build an electronic crossover system, a completely active speaker system, as I have, then there's no rules involved here. You hook up an amp, you use a certain electronic crossover, you use certain drivers, and you get a certain characteristic, and it may be pleasing or not. In this case, yes, they're very clean and bright, but they're a bit much to my ears, and I've come to recognize that. It takes a while before you really start to really understand, gee, this system's a little too bright, maybe. So now all I've ever driven this is actually a secondary tri-amp system that I just finished building. I haven't finished the video on, but the active speaker system that I listen to all the time has the brothers of these. I bought them as a replacement. They're the exact same tweeter. They look a little different, but they sound identical. And I'm driving those with another Rotel 1050. And they are really bright. And so it's wonderful at moderate volume levels, and especially with older recordings, but you get into newer recordings and you're turning it up, the highs can be a bit much. So that's kind of what's driving me to kind of look at the amplifier. I have gone through the rest of the system, and I've got videos on that on the interconnects, and I've looked at speaker cable, and I've looked at actually tweeters. My video on tweeters, I actually swap out, and I try soft dome tweeters, and I tried the Etons I mentioned, and so. But I've determined that I'm going to stick with my focals, or today I would buy Etons. But now I've got to voice that system because I got to get those tweeters to not be quite so bright. Now the Rotels tend to be, especially these 1050s and probably the later generations, they tend to be very clean and crisp and bright, and maybe they lack a little warmth. That's some of the feedback from folks. So I'm thinking, and I did this about a year ago, I'm thinking maybe this amp is really the source of some of the problem I'm having, this amp being so bright. I wonder, I have a couple of other 50 watt per channel amplifiers. Let me try those. So I swapped out with my old RB850, it's about 30 years old. The 1050 is about 10 years old, and this 951, I'm sorry, is about maybe 20 years old. So they're different models, the 800 series, the 900, the 1000 series, from different generations, different decades. So I put the 850 for just, remember it's a tri-amp system, so I have 3 amplifiers for each of the pairs of speakers in my tri-amp system. So I have an amp just driving the tweeters, an amp just driving the mid-range, and an amp just driving the bass speakers. So what's nice about that, you can swap back and forth very easily. So I've been listening to, this is my other, the other tweeters with the other 1050. And listening to that for over a decade, and I was used to it, but I'm deciding it's a little bright. So I put my old RB850 in there. Definitely there's a difference in clarity, in character. Pretty remarkable. It would not be subtle. Anybody listening to the system, however, might fine-tune their ears, would be able to immediately hear the difference. So it's not a subtle difference I'm talking about here, whereas I've talked about differences with interconnects and with speaker cable, and those differences are subtle. You can hear them if you pay attention, but they're subtle. They're not going to knock you over. Whereas this, very definitely you notice it. So that's pretty incredible that an amplifier can make that much difference. I proved that to myself. Well, then I went and swapped out this old 951 that I bought used, thinking, well, maybe it'll be between these two. Well, it turns out this one's even less brilliant. And remember, I'm just using these for the tweeter, so I'm only listening 3,000 cycles up. This is much less brilliant, much less bright than the 850. And the 850 was a considerable step down from the 1050. So I proved that a year ago, just how much difference an amplifier can make. And that really is just, of course, in the upper range. There'll be other differences and other kind of characteristics you can look at for, say, the bass. The bass, I think, a big, more powerful amplifier would sound better than a lesser powerful. I've proven that before. Putting a less powerful amp in place of a more powerful amp for the bass, and heard a significant difference. Even though you drive the amp the same amount and you get the same amount of output, but boy, there's just a different character to the bass. So amplifiers matter. And so what we're doing here is we want to chase and look at what other options I might have. So one of the thoughts I had for getting an amp maybe that would be a little warmer for just the highs. That's all I'm chasing right now. I'm very happy with the bass. I have a nice Rotel 130 watt per channel amp for the bass. I'm happy with that. If you're going to drive bass speakers, you need lots of power. So mid-range, I got a good quality mid-range driver that matches the tweeter. I'm very happy. I've listened to other mid-range drivers in that system and heard a difference. So drivers matter, but in any case, I'm very happy with those drivers. And even with this, less brilliant 951, it sounded okay. This amp drives these speakers in this new system. I'm okay with that, but it's the high end that I'm really chasing after here. So knowing the amplifiers matter, what I was thinking about some other options. So one option is to get a tube amp, and there's a manufacturer out there that's making the old Dynaco ST70. It's a traditional tube amplifier with 12AX7 front stage and then push-pull 6L6. That's what we use, the American version 6L6. They use the EA34, I think is the European equivalent. And that's very similar to a tube amp my father had us build back in the day. He's the electronics brilliant engineer. I'm not an engineer in electronics. I was more in the mechanical things. That's my gift. So I relied on him, and he's long since passed away, so I don't have his brain to pick anymore. But anyway, he designed us tube amps, my brother and I. We built tube amps with 3 stages of 12AX7 or 12AU, depending on if you want to drive the stage a little harder, and then push-pull 6L6 output. So I was familiar with tube amps and generally how they work, and so that's that knowledge I'm bringing to this project here, although I don't know design. I never studied it. I never really wanted to bother for whatever reason, so my father was the brilliant brains on that. But anyway, so the tube amps, I'm familiar with that. I was tempted to buy a pair of one of those ST70s. It's a kit for $1,000. I still want to do that. It'd just be fun, and then maybe drive a pair of 8-inch 2-way passive speakers with them. That would be a fun project to do someday. Take me back to the old days when I built an amp with my father. That would be fun. So that's one thought, but it's $1,000 just to drive the tweeters. So that's a little steep. And so I was thinking about that. Maybe someday I'll try that. But the other option, been listening to Phil McGowan. He's the principal engineer designer, one of the principal engineer designers for PS Audio. And he's an old guy like me. He's in his 60s, and he's doing these 5-minute videos every day. And he talks about amplifiers a lot. In fact, just this morning I was listening again. He's talking about tube versus transistor. His position is that tubes work great, and he explained why. I don't know the electronics of it. I can't replicate that. But he explains that tubes are great in the front end, in preamp, or front end of an amplifier. No amplifier has just a single amplification stage. It has multiple stages of amplification. That's why we had multiple 12AX7s front end and then a push-pull 6L6 output. You need to amplify the signal in a number of stages to get up to a point where you can drive speakers with it. But anyway, so he would have tube, and he has amps that he builds for this. They're ridiculous money, but tube front end, and then he has transistor output. So that I actually naively called Phil Marchand, who's provided the electronic crossover for me and a number of other crossover stuff for me, and asked him, hey, can you build me a tube amp with a tube front end and transistor MOSFET output? No, Jeff, that would take years to develop that. So amplifier design is not a simple thing. and that was very naive on my part to ask him that. But so he has these, I'm going to show you in a little bit, he has these MOSFET amps we're going to modify, and I'll get to that. But so that was another option, do tube front end transistor output. That, going back to Paul McGowan and his PS Audio stuff, he recommends using transistors for output, especially MOSFETs, and using tubes for the front end, or a tube preamp, or a tube phonos preamp stage to bring your cartridge, 1/10 of a volt cartridge up to a couple of volts. I'm thinking about doing that. That'll be fun someday. So that's out. So I'm not going to do the tube. I'm not going to do the tube transistor combination. Those are out of my reach. What other options do I have? There is an amp I just found in a catalog I didn't know existed. It's a MOSFET amp. It's $1,000. That would be fun. I could buy it. I could try it. I could return it if I didn't like it. But the other option I had, speaking again of Phil Marchand from Marchand Electronics, he makes MOSFET amplifiers. This is a MOSFET amp, and so and this is a single channel, and then you buy two of them. They're not cheap, $200. You got two of them now. You're $400. You had a power supply. You're $470 before I've put it together. You still need a transformer. You need a case, all that stuff. So it's not a cheap way to go, but it's going to be in the $500-600 range to do that. But so that's a way to get into MOSFETs. It'll be all transistor. There won't be a tube front end, but that's my next challenge, to build and amplify in MOSFET and try the MOSFET. So now there's two kind of different, I mentioned tube, I mentioned the tube transistor combination. The third kind of differentiation of amplifiers is, on the one hand, what's called a BJTs, or bipolar junction transistor. This is all from Paul McGowan. I don't know this stuff as well as he does, but he explains most of these amplifiers are using a BJT transistor outputs. And the alternative is the MOSFET. MOS is a metal oxide semiconductor, field effect transistor. That's what MOSFET stands for. Again, I don't know the electronics. I memorized the name. But so BJTs are the traditional kind of a transistor output. MOSFET is the alternative. The word on the street is that MOSFETs sound more like tubes than the BJTs. And it's because it's a completely different architecture and structure. A different way of making a transistor work. And I don't need to know all the ins and outs of it, because I'm not going to design these. I'm going to take Phil Marchand's amps and I'm going to put them in there and try them out. So that's my task now, is to build an amp and try the MOSFETs out. Because I've never listened to a MOSFET. In fact, in my top of the mountain system with the identical tweeters to these, and with this new system, I've only listened to it through the 1050s. That's all I've ever heard it with. So I don't even know, what would a tube amp sound like driving the tweeters? What would this MOSFET? What's this MOSFET going to sound like driving the tweeters? So that's the task before me today. Let me go in and show you what this amplifier looks like. What I'm going to do, I could buy a new case and all the switches and all the electronics and stuff to build this amplifier. This I can't do, but the rest of it I can. And he has a power supply, I'll show you. And you just hook up the stuff. It's not really hard to do. You have to know a couple of things, but it's not. The rest of it, once this is done, it's designed and built. The rest of it is relatively easy for me. I can do the rest of it. So what I was thinking about, of course, you can buy a case and then buy the switches and you have to buy a relay. You can't run all the full power through a switch. You have to buy a relay. You can buy those. And then you buy the RCA interconnects. You buy the speaker connections that bolt onto the back of the case and all that. So you buy all the parts and you put it together. It's not really hard at this stage. This stuff you can do. But I was thinking, I'm unhappy with this 951 after testing it out against the other two here and hearing how much more subdued it is in the high end than these. So I have a case. I have, in fact, there's a transformer in here, the toroidal transformer in here that I can use. I have a switch. I have the relay inside. I have all the stuff I need. I could just take the guts of this out of this case and put all this stuff into this case. And I even have, in this case, the heat sinks that I can bolt these to on either side. So let me show you what the inside of this amp looks like. We'll take a look at how amplifiers are designed and what I'm going to do. Okay, so I've set the camera so we're pointing straight down at this amplifier. I've taken the cover off. so we can see the internal stuff. And it's really not all that complicated. It looks really complicated for those unfamiliar with this, but it's really not that complicated. It has a couple of basic components. First, you have your AC power coming in here. This actually goes through a fuse. And then you have the power cable coming up from there through a relay. And now your switch operates on the front here, operates the relay. So all your power isn't going through the switch, but just a small power going through the switch that operates the relay, and all the big power that drives the transformer goes through the relay. And relays can burn out, of course. But then you have power leads coming off the relay to the transformer. Transformer has to take your 110 volt power from your house, your AC 110, and bring it down to a voltage that an amplifier is going to use. And anywhere from 25 to 50 volts. Marchand's amplifiers can run up to 65 volts to get 200 watts. This you could use a 35 volt transformer, and that would get it into the 75 watt, which is what I want to do. It happens these transformers are running about 33 volts. So we're going to use these transformers for this new amplifier. But anyway, so the transformer we can reuse, which is great. I don't have to buy that. I will have to move it, but I don't have to buy another one. Then out of the transformer, the lower voltage, 33 volts, now comes into the circuit board and through a set of fuses. And then we have to convert that AC voltage to DC, from alternating current to direct current. So we have a couple of diode packs in the power supply that Phil Marchand provides. We actually see the diodes in their individual diodes, the 4 individual diodes for the power supply. In this case, we have them this way, so they don't look like traditional diodes. But in any case, that diode pack, that bridge diode, I built bridge diodes. My father had me building those when I was a kid. And he explained all that, and I've lost that understanding. But in any case, it's got a bridge diode network, or rectifiers is what it's also called. In the tube, there are tube rectifiers and all. But anyway, it converts your alternating current down to direct current, and then into a line of capacitors. And here are the capacitors, and that provides stability for your DC, and a little bit of sort of a reservoir, so you can draw a lot of power from it, and then they'll recharge back up instantly. So that's kind of basically how the supply works for the amplifier. What's really interesting is that the signal comes in and is not itself amplified, but rather an analog of that signal is generated by the transistors. And that analog, that's really the electrons from your power supply, are what goes out to your speakers. So that's really kind of interesting. So this power supply is really what's going to ultimately be driving your speakers. So this power supply is a very important component in your amplifier, because it's really where the electrons are coming from, where the electrical power comes from, that actually drives your speakers. This is going to color your sound of your amplifier. And so it's very important. So we got to get the power supply right. In the old 850 that I showed you earlier, the RB850, it had 2 smaller transformers and separate power supplies. So, but more traditionally in amplifiers, they use these big toroidal power transformers and a pair of coupling capacitors each side. So, and in fact, Phil Marchand's power supply that he provides has 6 capacitors. So that's really cool. Lots and lots and lots of power. There's a good reason, I'm sure, why he provides 6 instead of 4. I've only ever seen 4. But in any case, now we have a power for the various transistors. Your signal comes in, goes through its amplification stages, and out to a set of, in this case, the BJTs, 4 BJT transistors, output transistors. They have to be mounted to a heat sink, because they'll get hot, and you'll have to draw the heat off the transistor, or of course you'll burn it right out. So these aluminum heat sinks soak the heat up, transfer that heat very quickly. There's very important transfer pads here that allow the heat to be transferred very quickly from the transistor component itself to the heat sink. And now the heat sink gets warmed up, and air, of course, there are vents underneath the steel chassis that allow air to rise. So these heat up, air rises through the vents at the top of this, and air goes underneath and goes through. You don't really need to fan it. Some amplifiers, well, a fan would be noisy, I don't know. Computers have heat sinks on their main processors that actually have a fan on it, because it really gets hot, and you got to keep it cool constantly. In this case, it's a more passive arrangement. They heat up and the heat rises and the air flows that way. So that's basically it. That's all there really is to an amplifier. Now for my project, what I want to do, I'm going to, as I mentioned, have to move the transformer. Maybe I'll move it over here. My power supply will need to be mounted on this side. So I've got to make room. It's not going to quite make it. I'm going to leave the heat sinks and reuse them right where they are. So this power supply has to sit about there, if you can see that. Has to sit just the other side of that heat sink on that side. So that transformer's got to move over. And then my amplifier channels will then mount onto those heat sinks on either side. One there and one there. So that's the plan. I'm hoping I won't run into any snags. So I wanted to do this video and show all that, and now I'm ready to take this all apart now that I've got this on film. And I will then come back and I will show you what my progress is. I'll show it to you next. It may be a few weeks down the road from the taping right now, but when I'm finished, I'll come back and I'll show you what the project looks like. And that way I will have converted this BJT amplifier into a MOSFET, and without having to buy a new case. So it'll look real nice. I'll reuse most of this. The switch I'm going to replace. It doesn't have a ground on it, so I've got a new connector because there's a ground on this connector. There's no ground on this one, so they kind of cheapened there. But so I'm going to have to modify and then mount my. I've got to mount the speaker connectors here. I've got to figure that out. What problems I'm going to run into. Mount my new RCA connections. I've got also a special goop that you use to, when I mount this, even though these transistors are already mounted onto an aluminum plate, they have to be mounted to a heatsink. And these are a bit small, but that's because it was designed for 200 watts. I'm only running it at 33 volts. It's barely going to produce 75 watts output probably. But nonetheless, I want to put some material on here. I'll put 4 screws in here, drill and tap this, mount this onto this aluminum plate. But I'm going to want to put some material there so the heat transfer from this aluminum plate gets to this aluminum heatsink, transfers very quickly. So that's my plan. I will end at this point. We'll come back when I get this finished, maybe several weeks, and we'll take a look at what I've got. So here's the amplifier all assembled now. And I've been listening to it for a bit. Let me point out some of the details of the build. First, that the transformer had to be moved over. So I've moved that over. Just re-drilled the hole for the hole down. Kept the wiring in place completely. Reused the relay, as I mentioned, and it's all of its wiring. That all was kept the same. I replaced the connector and put a ground lead on there. And that's it. And now I come off the secondary of the transformer, mounted the power supply here. Now secondary goes here, and then out to at low voltage. Interesting point I'll make is that the AC output is 33 volts, and so I assumed a DC output would be 33 volts DC, but AC and DC are different animals, and so it's actually outputting 44 volts of DC. I don't understand exactly why 33 and 44 out, but in any case, that brings the power output up a little bit. So instead of 75 watts, I'm probably running in 125 watts. So you can run these again up to 65 volts DC, and that will drive them up into the 200 watt output range. But because I'm running down at the lower output, I don't have to have the recommended larger heat sinks, and if I were going to do that, I would have to have gotten different heat sinks and probably a different case and started over. So using these heat sinks I was necessarily going to have to limit myself to the power output. Now mounting these onto the chassis, I use these coupling nuts. They're basically a wide nut threaded all the way through, so you can put screws on either side. And there were some that came with the amplifier where I moved the old amplifier card. It had some of those, and then I had some extras from rebuilding computers that I used here for the power supply. You can buy these connectors of various lengths at the hardware store. So the key was to get the holes drilled properly for proper location, and I didn't take as much time as I should have to identify precisely where those holes should be drilled, and I should have then used a punch to start dead center where the hole was, and then pre-drill with a smaller drill, and then move up to a larger drill to size to get the clearance. And especially here, the power supply, I probably needed to make a template for the power supply. I made just a hard card with the holes precisely located, and then put the hard card down here and use a punch or whatever. And I should have spent some more time on that in any case. The final solution, though, is the hole in the chassis can be drilled a bit large, and then those can move around a little bit, so there's a little bit of flexibility. A couple details about that. This power supply requires, it's called V plus and V minus and then ground. And the amplifiers require V plus and V minus. Actually, it's V plus on one side and V minus on the other side. That's how they're designed. So it's V plus and ground, V minus and ground on either side. And so you just have to make sure that's all correct. Just double and triple check your work. I used wire, whatever I had left over from the other amplifier. So this is adequate size, but the colors don't all match up. If I could have gone out and bought wire. That would have all be, the colors would all be exactly the same. All the V pluses would be the same, the V minuses would be the same color, but whatever. I did use the FT4 AudioQuest speaker cable wire for the speaker connections. So that's kind of, maybe it's a little overkill. And then the input connection coming in, the signal input, I have these Mogami. This is actually, this is the Neglex wire. It's by Mogami, and it's got 4 wires. If I could do it this way, 4 wire connections, and you run plus these and minus these. So, and it's a balanced signal then, a balanced wires going from one end to the other. And I didn't shield them. No need. The metal case provides shielding for the entire amplifier, so you don't have to really shield the input connection from the connector here into the amplifier card. So these are the speaker connectors that I bought. Happens to be that the holes were drilled in exactly the right place to mount these. However, the mounting really wouldn't work. The hole was a little bit too big, so I had to create, I don't know if you could see it on the back side, but I cut out a piece of steel for that I had just in my stuff, drilled the proper hole size, and there was actually a little lock notch on them that had to be filed. Mounted that with a couple of screws onto the back here, and then these are really attached to that metal plate, and the hole is just an access. These are much easier. They just bolted right in to the connectors. Obviously, these are designed to open up. You stick the wire in and you tighten these down, right? Actually, I have connectors. They're spade connectors that set into the 2 spots here, and this is entirely protected by plastic all the way around. They work perfectly for the spade connectors that I have, better than the other amplifiers that I own. So they're really great in that way. But the other advantage, if you locate the position of these just right, then you have these connectors. They allow for, they have little tighten downs. You put the wire in the holes, tighten these down, and they become a quick disconnect. And the distance has to be just right for these to work, and it is, of course. So, of course, there are some holes in the back that are now open that aren't used, and there are some features here in the front that aren't used any longer. There's no longer level controls and lights and all that stuff. One of the things I failed to do was to reutilize the LED light that was here. I didn't measure the voltage coming off the power supply to this lamp before I disassembled it, so I could not tell what the voltage was that drives these little lights. So that made using those pretty impossible. I did order some bulbs, and I'll just maybe drill a hole or something and mount the little bulb here. And that's a 12 to 20 volt DC supply requirement. So obviously I'm going to have to come off 44 volts and reduce that with a resistor, maybe 1,000, 1,500 ohms. I'll have to sort of do a trial and error. I tried using Ohm's law, and I haven't been able to figure that out, how to get from 40 volts down to 12 or 15. So somebody else a little smarter than me can figure that out, but I'm just going to do it in trial and error, put a resistor in series and get the voltage down to and into that range, and then I can mount a indicator light so that when I turn it on, the indicator light comes on. Otherwise, there's no indicator light. That's not absolutely essential for me. I know when it's on or when it's not on. But otherwise, let me talk just a little bit quickly about how this amplifier works. The bottom line is, or the headline is, that I transitioned this old Rotel RB951 from the least high quality sounding amplifier owned to now the best quality sounding amplifier that I own. And I've certainly spent a lot of money, maybe as much or more money on this one as on any other ones that I have. I first put this amplifier into the tweeter circuit. Remember, I have a tri-amp system with 3 amplifiers. One that runs the tweeters, one the mid-range amplifiers, and one the bass speakers. So I first replaced the tweeter amp, which is that old RB 1050 you saw at the beginning of the video. I replaced that one with this one. The problem was the output of this one is so much higher than the 1050. And I have no output control on this amplifier like I do the 1050s. So I couldn't get the volume of this one down adequately relative to the others. So that wasn't going to really work. The other thing I noticed right away is that there's plenty of highs in this one. This is just as bright as the 1050s. So I'm not, I actually was hoping that it would be a little bit more temperate, a little more subdued, a little softer. So that's not the case at all. Next thing I did is I replaced the, I have a pair of 8.5, 8-inch 2A speakers rather, that I listen to, just passive speakers. And I replaced the amplifier I drive those with, the 850, RB850 that I showed you again at the beginning, the other amp, with this one, and immediately much better highs. Bass is about the same, but much better highs. The next experiment I did is I took my old active speakers project, with an 8-inch 2A active system, and it has 2 amplifiers, for tweeter amp and bass mid amp. So I replaced the bass mid amp with this one. And wow, that was a big difference. It's much nicer sounding. So I could really hear that difference in the bass mid. Not in the low frequencies, but in the mid frequencies, actually. So now I put this amplifier into my active tri-amp system, what I call the top of the mountain system, and I replaced the mid-range amp with this one. And so I'm happy with it. So it's working out very well in that position. So that's a little maybe unique compared to other listeners. They might have just one amplifier running passive speakers. So, but even still, as I say, against the 850, the old RB850, which is again arguably a 30-year-old amp, but this one I didn't compare this one to the 1050 in a full range system, but. So, but anyway, it was a fun rebuild, and I'm very happy with it. And so feel free to leave any comments, and we'll see you next time.